Hello everyone, I am Bibek Biswakarma from the Department of Electrical Engineering, Tezpur University. Today in this PPT, I am going to discuss about the BET algorithm. Now, here is an outline of what we are going to discuss. Firstly, we can learn about what is BET algorithm. Secondly, we will see what is ecolocation of the microbats. Thirdly, we will see the characteristic of these microbats. Fourthly, we will see the basic step involved in this microbat algorithm. Fifthly, we'll discuss about the application. Now, what is BET algorithm? BET algorithm is a biological inspired algorithm developed by Young in 2010. BET algorithm using frequency technique to increase the diversity of the solution in the population. BET algorithm uses the automatic zooming to try to balance exploration and exploitation during the search process by mimicking the variation of pulse, emission weights, and loudness of BET while searching for prey. Notice what is echolocation of microbats. And there are thousands of different species of bats. These bats can range from 1.5 to 2 gram, which are primarily known as the tiny bumblebee, or there may exist giant bats, which can weigh up to 1 kg with a wingspan of about 2 meters. Microbats mostly uses this echolocation process extensively, while the megabats do not. Here is a diagram of echolocation of the microbats. As shown in the figure, sonar sound is sent by the bats, and when it is returned by measuring the duration of the sending and receiving sound, the bats came to know about the distance between its prey. Also, sometimes it can be seen that the sonar sent to the object may not be a prey. It may be some of this background. Then it may, but this bat had this ability to distinguish between its food prey and the surrounding. Now, what are the characteristics of the microbats? All bats use echolocation to sense distance, and they also know the differences between the food prey and the background barriers in some magical way, as I've already said. Suppose we assume that a bat is flying with a velocity vi at the instantaneous position is x1 with a minimum frequency f9, f minimum, and varying wavelength and loudness x a0 to search for its prey. They can automatically adjust the wavelength or frequency of their emitted pulse and adjust the rate of pulse emission from ranging from 0 to 1 depending on the proximity of their target. Now, what are the basic steps involved in the BET algorithm? Firstly, we set the initial values. That is, we set the minimum frequency, the maximum frequency, the population size, the loudness constant, the rate of pulse emission, the initial loudness A0, and the maximum minimum loudness A minimum, the initial rate of pulse emission R0, and the maximum number of iteration M AXITR. We set the counter initialization at t equal to 0. For I less than 1, we firstly generate the initial bat population XIT randomly. Then we generate the initial velocities VIT randomly. Then we assign the initial frequency Fi to each of this position XIT. We evaluate the initial population by calculating the objective function FIT for each solution of the population. We set the initial values of the pulse rate R and loudness AI. Now we again repeat this process for counter iteration at t equal to t plus 1. We generate new batch solution XIT by adjusting the frequency, which will be shown in figure equation 8. We update this velocity VIT as shown in equation again, which will be shown later. Evaluate this population by calculating the objective function xit for each solution of the population. We select the best solution x star from the population. If the randomness is less than Ri, then we select a solution among the best solution. Then we generate a local search solution around the selected best solution. And we end the result. If the generated new solution randomness is less than AIT, then we accept the new solution. Otherwise, we increase the rate of pulse emission Ri and reduce the loudness A0. Again, we evaluate the new population by calculating the objective function FIT for each solution of the population. We rank the population and select the best solution x star from the population until t is less than MAXITR. Then we end this process, then we produce the best solution. Now discuss briefly, we see that we start the algorithm by setting the initial value of the parameters, and the mean iteration counter is set to 0, which is only equation 1 and 2. We said the initial population is generated randomly. The initial position x0 and the initial velocity v0 for each bat in the population. The initial frequency fi is assigned to each solution in the population. The initial population is evaluated by calculating the objective function for each solution in the initial population fi0, and the values of pulse rate Ri and loudness Ai is initialized, which is shown in equation 3 to 9. The new population is generated by adjusting the position xi and the velocity vi for each solution in the population as shown in equation 6, 7, 8, lines 12 to 13. Here fi equal to f minimum plus f maximum minus f minimum into beta, and vit equal to vit minus 1 plus xit minus 1 minus x star fi, where xit equal to xit minus 1 plus vit, where beta belongs to 0, 1 is a random vector drawn from the uniform distribution. The new population is evaluated by calculating the objective function for each solution, and the best solution x is selected from the population. The local search method is applied in order to refine the best found solution at its iteration 16 to 19. The new solution is generated randomly and expected with some proximity depending on the parameter V0. The rate of pulse emission increases and the loudness decreases. The value of AI and Ri are updated as shown in equation 9 and 10. AIT minus 1 equal to alpha AIT, RIT equal to Ri0 bracket I minus exponential of gamma epsilon, where gamma, alpha and gamma are constant. This parameter play a similar role in the cooling factor in the simulated analyzing algorithm. Step 7. The new population is evaluated and the best solution is selected from the population. Step 8. The population is repeated until the termination criteria is satisfied and the overall solution is produced. What are the application of this BET algorithm? It is used in continuous optimization algorithm. It can also be used in combinational optimization and scheduling. It is used in inverse problem and parameter estimation, classification, clustering, and data mining. It is used in image processing. It is used in fuzzy logic and other application. Thank you.